Don't worry, it'll go fast.
Wash.
It will be fine. All right, so we had agreed. Guys, I'm not gonna yell. I'm not gonna yell. We had agreed that this guy is our absolute value V, shifted 2 to the left and 1 down. We do not need anything any better than that. That is enough. We had discussed that there are no asymptotes in this picture. Remember, asymptotes are lines that the curve approaches, gets closer to, it doesn't intersect. So these would be asymptotes. We are not doing that. There is nothing controlling that picture. It's just going to keep getting bigger and bigger. Okay? Maximum or minimum? Does this thing have a maximum? Use your common sense. No, because it keeps going up forever. Does it have a minimum? Yes, and the minimum is that point right there. Does it have any symmetry? Now, we are going to spend some time with 4 symmetries. We're going to look at x-axis symmetry, y-axis symmetry, symmetry about the origin, and symmetry about the identity line, what we call the identity line. When you have a picture, you can just kind of eyeball it. In a bit, we're going to do it with equations. It's a little bit harder then. But we're going to, here we have a picture in front of us. Would you say that picture has symmetry to any of those things? Now remember, what does symmetry mean? Symmetry means, let's say do x-axis. If I folded my paper right here, would that curve double back over on itself? No. This guy has no symmetries. Doesn't have any. If you had a parabola that looked like this, does that have symmetry? Y-axis, because if you folded the paper on the y-axis, it would just be on top of itself, mirror image. Not x-axis. You can fold it over, but it doesn't land on itself. If you fold it this way, it lands on itself. Okay? This one, if I fold it anywhere, it's not going to land on itself unless I folded it across that line. But that isn't one of our special symmetries. So we're going to say no, it's not. All right, let's look at the next. Oh wait, there's a couple more. Domain, range, and zeros. What do you think the domain of this guy is? What's the domain of this guy? Any thoughts? All real numbers. We're going to say that like this, Mike, but all real numbers. Domain is which letter? X. How far right does this picture go? All the way. How far left does it go? All the way. There's no stopping it. Now, how about the range?
-1.
There's
-1
no Y's,
to infinity.
and that would be -1 to infinity. Because the curve starts at -1 and goes up. There's nothing down here. And how about zeros? What do we mean by zeros? Yep, those are x-intercepts. Where do we cross the x-axis? Well, you can tell clearly that you cross a couple of places, right? You may or may not be able to tell from your picture where you cross, but it looks like, I'm just eyeballing, it looks like -1 and -3. So I'm going to try it. If I put in -1, do I get 0? Negative 1 plus 2 is 1, and 1 minus 1 is
0.
0. How about if I put in negative 3? Negative 3 plus 2 is negative 1, but the absolute value is 1, and 1 minus 1 is 0. You could also solve this equation. If you're not sure what your zeros are, set it equal to 0 and solve it. So absolute value x plus 2 equals 1. There's negative 2 on the number line. I'm going to count 1 this way and 1 this way. There they are. Negative 3 and negative 1. With these simple pictures, you can often just eyeball and check if you don't know what you're doing. Okay, now we're going to rinse and repeat with a new shape. So, can anybody tell me what this looks like? Okay, it's definitely a parabola because x squareds are parabolas, right? Good? It's upside down because there's a negative and Finn up 3. So this parabola looks like this. Is it continuous? Yeah, there's nothing to break it up. It just keeps going forever and ever, so it is continuous. Would you say it is increasing or decreasing? Both. It is increasing from negative infinity to 0. Remember, when you write these intervals, it's x's. You're going left to right. So negative infinity to 0, I'm going up. And then from 0 to infinity, I am going down. Bounded above. Does it have a ceiling?
Yes.
It does. Bounded above where?
Negative.
Y equals 3. We're talking about up and down now, so we're talking about y's. Is it bounded below?
No.
No, it doesn't have a floor. It keeps going. See those arrows? This keeps going. Therefore, is it bounded?
No.
No, because the only way you can be bounded is if you are ceiling and floor. That's how you're bounded. You have a ceiling and a floor. That guy had any asymptotes? No. Don't make that concept harder than it is. Is there anything containing this? No. It's just going to keep on going. Jimmy?
But why can't the asymptote be the ceiling?
Okay, remember, an asymptote is a line that the curve approaches and doesn't intersect. So it will have this relationship with this asymptote. Okay? It gets closer to it as it goes up. Is that what's happening here?
No.
No. If I drew a line across the top of this, that ain't an asymptote because I'm not getting closer to it.
Yeah.
Right? Does this guy have a maximum or a minimum? It has a max at 0, 3. No minimum. No low point. Does it have symmetry? And I erased them, but remember we're talking about x-axis symmetry. Does this have x-axis symmetry? No. How about y-axis symmetry? Yes, it has y-axis symmetry because if I folded my paper right here, wouldn't this chunk land on that chunk and vice versa? That's what it means to have symmetry. You land on top of yourself. Domain, what's the domain of this stuff? How far left does it go? Negative infinity. How far right does it go? So therefore, there's your domain. All real numbers. How about range? Negative infinity to 3. And we're going to include that 3 because we actually have a dot there, right? And how about zeros? Yeah, I can't tell from here. So what I'm going to do is take my equation and set it equal to 0. So 3 equals x squared. And where are the zeros? Root 3 comma 0 and negative root 3 comma 0. How do you find zeros? You set your equation equal to 0 and solve it. Alright, now we're going to talk a little bit about the symmetries. I don't think we're going to do all of these problems, but I want to do enough for you to get a good sense of what's going on. So, the special symmetries are, fill in those blanks. Tell me, what are the special symmetries I have listed? Y-axis, x-axis, origin, and what we call the identity line, which is y equals x. Okay? Now, your job is to figure out if y equals 3x has any of these special symmetries. Now, I don't have a picture of this, and you could graph this one easy enough, but some of these are much harder. And so we want to have an algebraic way of doing it. Okay? So I want you to think about something. If somebody has symmetry to the y-axis, doesn't that mean that point would land over here on this point by symmetry about the y-axis? So if this is the point 1, comma 2, what would this be? Negative 1, comma 2? So in other words, to test for symmetry about the y-axis, I need to change the sign on x. So, here's my equation. If I change the sign on x, I would have this. Would you agree with that? Is that the same equation that I started with? Remember, if you're symmetric, you have to land on yourself. So is this the same equation that I started with? No, it's not. So this has no symmetry about the y-axis. If you have symmetry, your final simplified version, after you make whatever change you're making, has to be the same as the original. All right, let's try x-axis. Any guess what we do to find symmetry about the x-axis? Change the sign on y. So that would look like negative y equals 3x, or y equals negative 3x. Now remember, I have to match the original. Does that match the original? No. Any idea how we test for symmetry about the origin? what would happen to this point if I popped it down here across the origin? What would that point be? -1, -2, so I'm gonna change the sign on both. So back to my original equation, that's gonna look like this. I change the sign, make y negative, make x negative. Now, clean it up. Hey, does that simplify to give me my original equation? So that one has symmetry about the origin. Which means if you graphed this and folded your paper across the origin diagonally, it would land on itself. Alright? Y equals x. Switch x and y. So in other words, instead of y equals 3x, it's x equals 3y. Because if y equals x, you ought to be able to interchange them. Is that the same as what I started with? Nope. So that problem has symmetry about the origin. All right, pick another one on this page. You ready to do B, C, or D? B? Is B okay with everybody? All right. All right, so our equation is y equals 3x plus 2. We're doing our tests of symmetry. All right, so here we go. If we do y-axis first, we're going to change the sign on x. So y equals 3 times negative x plus 2. If you're going to say yes, that has to be exactly the same as that. Is it? I don't need to work it out. I can tell it's not. All right? Negative y equals 3x plus 2. I don't think that one's going to match either. All right, change both. So negative y equals 3 negative x plus 2. Now that one is a little bit tougher. You might want to actually work that one out. So negative y equals negative 3x plus 2. And if I divide by a negative, I'll have y equals 3x, oh shoot, minus 2? Is that the same as the original? Nope. And finally, switch x and y. So x equals 3y plus 2. Is that going to be the same equation? I don't think so, because if we get y by itself, it gives you this, which is not the same as that. So guess what? That one has no special symmetries. None. All right, turn the page. We're going to do one more from the back. Now I've made some notations about whether things are functions or not. Let's not worry about that right now. Let's just do our tests of symmetry and make sure that we can. So which one do you want to do on the back side? H? All right, we'll do H. you and your partner, see how far you can get. And I will do it too, and we'll see how we come out.
Do you change it on both too?
Yeah, yeah. If you're changing the sign on X, you change it on every X. First time?
Negative Y, right?
Oh, yes. All right, we were doing the last one. Did you find any symmetries? Origin, let's check it. That would be negative y equals negative x cubed plus 2 negative x. That is a mess. But we know that negative x cubed is negative x cubed minus 2x. And if we divide by the negative, I think you're right. It does have symmetry about the
Are you
origin.
saying that we check the y equals x?
Check
Yeah,
the y
just so I
equals
can,
x.
I want to see how you can
So
solve that.
x equals y cubed plus 2y.
Yeah. Or- yeah.
You just have to recognize there's no way y cubed is gonna be the same as x cubed all the time. Right? The only way to do that is to solve it implicitly and we can do it. All right, so we okay with that? All right, so now we've got a new vocabulary word, even and odd. Now, I know you've heard those words before and you know what even and odd mean, but in terms of a function is even if it has symmetry about the y-axis. So if someone says to you, is this function even? You're going to do your y-axis test. And what is your y-axis test? Change the sign on x. Right? If it's a yes, then you're even. Odd means you have symmetry about the origin. And that one's easy for me to remember because odd and origin. So if something is odd, you will change both signs and hopefully they cancel each other out. Symmetry about the origin. Okay? Alright, number 5, find the domain. Well, I don't know, there's a whole bunch of them. Anybody want to guess at any of them? Do you have any guesses about any of them? What is domain, by the way? Domain, which letter? X's. So it's the X's that make the problem make sense. Which X's can be graphed for this whatever function is you're looking at. Anybody have any ideas? Yeah, Finn? What?
For letter A, snagging
It's all over. Absolutely. The first one has no problems. What causes problems with domain? Well, B has a problem. What's the problem with B? X can't be 3. Why can't X be 3?
Because 3 minus 3 is 0.
And you can't have a 0 in the bottom. So one of your red flag areas is if you got a denominator. Because whatever is down there can't be 0. So for B, your domain is everything to 3, and then everything from 3 on. So in terms of the number line, it's just everything but 3, right? So that's your domain for B. Now, can you do something similar for C? 3 is called an excluded value. You can't have 3. Look at problem C. Is 3 still an excluded value? Is there any other excluded value? 0. So in problem C, you can't have a 0 and you can't have a 3. Does that make sense to everybody? Denominators can't be 0. So what would be my domain here? If X can't be 0 and X can't be 3, how would I write my domain? Negative infinity to 0. 0 to 3. And then 3 to infinity. It's awkward. That's how we have to do it. Let's skip down to F. Tell me about F. Does F have a denominator? Denominators cannot equal 0. Okay? So tell me about X. Can't be 2 or negative 2. For F? So I can't be 2 or negative 2. I'll write that down over here. So that'll be negative infinity to negative 2. Negative 2 to 2. And 2 to infinity. Now, if it helps you to draw a little picture of that, absolutely do it. There's a lot to keep track of. Alright, what's my number 1 domain rule? The denominator cannot be 0. So if your denominator is 0, that's an excluded value. Right? Get out of it, get out of it. Can't have it. Alright. What about G? Finn? It would be, Finn. You want to explain that to your peers?
Because there's no value in X, but it's going to make the denominator.
Exactly. Beautifully done. So x squared plus 4 will never be 0. Because if you square something, it will be positive, and when you add 4 to it, it's still positive. So there is no number that letter G can't be. Alright, one more time. My number 1 domain rule is Denominator cannot be zero. Alright? But there is another domain rule. Look at problem E. Look at problem E. I know for a fact that x can't be 2. Would you agree with that?
Yeah.
But that numerator causes me some problems because I have a radical. And what do I know about things under a radical? They can't be negative. They have to be positive. Because what happens if they're negative? Then we've gone to the other side. We become imaginary and we're going to keep it real. Real, real, real. Chapter 1, functions, real. Everything's real. So tell me about x. If that has to be positive, then what do I know about x? Well, if x plus 3 has to be positive, then x has to be bigger than or equal to negative 3. So you already told me I couldn't be 2. This was problem E. So here's my number line. I have an open dot at 2. But now you're telling me I have to be bigger than or equal to negative 3. So what's my domain for problem E? Oops. Negative 3 to 2, or 2 to infinity. With only the wildest, weirdest special exceptions, you will be fine finding domain if you remember 2 things. The denominator cannot be 0, and if you're under a radical, you gotta be positive. Okay? If you remember those 2 things, then domain is not gonna cause you any problems. So let's look at this hard one. D. Alright, there's a lot going on. Tell me what you can tell me about D.
We're under a radical.
We're under a radical. So 4 minus x has to be bigger than or equal to 0. It has to be positive. Be careful when you solve that. I'm gonna have to switch my sign. So x is less than 4. So on my number line, here's 4. I'm going this way. Is there anything else about problem D that bothers you? Can't be negative 1, so here's negative 1. I'm going to open dot there. Is there anything else that bothers you? No. Mike's shaking his head no. There is another piece to the denominator, x squared plus 1. But remember, can x squared plus 1 be 0? No, because you're going to square and add 1. So that one I don't even need to worry about. So for that problem D, I'm negative infinity to negative 1, and negative 1 to 4. And 4 is included. There's a lot. That's why we're seniors, we're big kids now. All right, vertical line test. Is it a function? Okay, this is easy. Is A a function? A is a function. Vertical line test, remember that? B is not a function. Now, C is an equation, not a picture. It's easy when it's a picture. What does this look like? What is that? What shape is that? Parabola, opening up or down, right? Depending on positive and negative. So what do you think this is? If this is a parabola, up or down, what do you think that is? It's a parabola, left or right. Y squared is a parabola left or right. Y squared, or squareds are parabolas. If you're x squared, you're up and down. If you're a y squared, you're sideways. Is a sideways parabola a function? No. So C is a no. What about D?
Yes, because it's long.
Jimmy
Yep.
says yes, and
Yep.
so does Michael. Michael says yes because it's a line. Isn't this thing a line?
Yeah, and it's
You
weird.
get y by itself and do y equals mx plus b, and there you go. It's a line. The only line that won't be a function is a vertical line, and you'll recognize that a million miles away because it's x equals something. That's what vertical lines look like. So as long as you got a line with a y, you're good to go. All right, identify the type of discontinuity. We talked about this yesterday. Does anybody remember what we talked about in terms of types of discontinuities? What? So we have removable ones. And Harper, how do removable ones happen? Do you remember?
There's a hole and you cancel out.
Because you can cancel out. Perfect. Let's look at our equation, Harper. We have x cubed plus x over x. Can the numerator factor? We can take out an x. Is everybody following along? I feel like I'm getting excited here. I love my discontinuities. And as soon as I factor that out, I can cancel. And when I cancel an x out of the problem, it's a removable discontinuity. So if I were going to graph this picture, which I'm not right at this moment, but soon I will be doing that, I would have a hole at that point. All right? If you type in your calculator, I don't think it's going to show you that. I think the calculator does the simplification automatically, and it graphs. Now, do you have a newer calculator? Mine does not. Maybe the newer ones do.
Can we even see it? I think it'd be so small.
Hmm?
Would it be like tiny?
Yeah. Yeah. Okay. What about this one? Y equals x over x minus 2. What are some other kinds of discontinuities?
Jump.
What?
Jump.
Jump. Non-removable, which is also called an infinite. And that's what happens here. Because we cannot cancel out the x minus 2. Would you agree with me?
Yes.
So this one would have a non-removable, or sometimes called an infinite. And that means it has an asymptote. A vertical asymptote. And where is the vertical asymptote? At x equals 2. Because we just talked about it. What happens if x is 2? You go to 0. Can't do it. So we put an asymptote there that says, okay, x can't be 2. The picture breaks right there. You can graph over here, you can graph over here, but you can't graph there. Wow. Okay, next page. Even, odd, or neither. And I'm gonna have you work on these by yourself for a few minutes with your partner. Let's review. Even means what? Y-axis. And what's your test for y-axis?
Change X.
Change x. And then odd is the origin, and what's your test for origin? Change your control. So there's only two you need to do. You need to do the y-axis symmetry and the origin symmetry. So let's go. Let's see if we can get this done. Then we'll talk about asymptotes. And then we'll be ready for our BFF. Jimmy, you done?
Not
Are
quite.
we making the F of X? That's Y?
Yeah, f of x is y.
When we're switching it, we make F of X X.
No, no. Oh, yes, yes. What do you mean when you're doing, yeah, but we're not doing the identity. The identity is where you switch the variable. We're just doing signs. So, Alden's point is a good one. F of x is y. So think of f of x as y. And then make negative y.
Can they both be even odd or no?
Can you be even and odd? You absolutely can. You cannot be a function and be even and odd, but you can be even and odd. I'll give an example.
Yeah.
You got it? Okay, what did you come up with? Cooper's gonna share his answers. Let's see where he's at. What'd you get, Cooper?
I got odd, none, odd,
Okay, so odd none, odd none. Alright, so one stack is odd, none, odd, none.
Remember that
Okay? Anybody want to agree with any of those? Anybody want to agree with any of them?
I agree with them all.
All of them?
I agree with that.
Okay. Let's talk about it, because I don't agree with all of them. I agree with a couple of them, but not all of them. So,
Which one?
problem number one is x to the fourth. If I am odd, then negative y equals negative x to the fourth. Now that could be a problem. Remember, you're changing the whole x into negative x. So that is not this. That's not what you're doing. You're replacing the x with a negative x, and then you're going to fourth it. So negative y equals x to the fourth.
No.
Does that match the original? No. What about even? What if all I did was change the x? What's negative x to the fourth? X to the fourth, which matches the original. This one's even.
Great, what you get like that?
All right, how about the next one? I disagreed with this one too. Square y equals square root of x squared plus 2. I said it was even. Did anybody else say it was even?
Alden, I did.
Oh, because it'd just be x squared.
Because when I square this, doesn't it just become
Yeah,
x squared?
yeah, it's just a bad block.
I thought C was odd. And I thought D was odd. And I thought E was neither. So I'm happy to do any of those you want me to do. These I think are the right answers. So I'm happy to go over anything you're not sure about. testing a function that you are negative x to the power, like that, you gotta put it in parentheses, okay? Alright? Alright, let's find all the asymptotes. I don't know if we'll get this done or not, but let's give it a shot. Find all the asymptotes. Look at problem number 1. It has a vertical asymptote and a horizontal asymptote. Anybody want to take a wild guess what the vertical asymptote is? What is the non-removable discontinuity? Will that cancel out? So what can x not be? X equals -1 is your vertical asymptote. Vertical asymptotes are cannot be. X cannot be -1. We already talked about that in terms of domain, and now we're talking about it in terms of vertical asymptote. They're the same thing. If you're a cannot be, you're not part of the domain, and you are vertical asymptote. Now, how about the horizontal? Anybody remember this from last year? I know you guys did it. It's a little trickier. Do you remember looking at your fraction and comparing only the x's? So what would be my horizontal asymptote? Y equals 1, x over x, x over x, y equals 1. Here's the idea. If x gets really big, like 1,000,000,000, the numerator would be 1,000,000,000, and the denominator would be 1,000,000,001. Isn't that about the same? So it's basically 1. It will never exactly be 1, but that's why it's an asymptote. It's getting close to 1. Alright, how about B? Vertical is x equals -3. Asymptotes are equations. X equals -3, because the denominator can't be -3, right? Or I shouldn't say that. X can't be -3 because the denominator can't be 0. How about a horizontal this time? Y equals 2, Alden. Y equals 2. How did he get 2? We look at just the x's. So he has 2x over 1x. And again, those other numbers are important, but not when you're talking about billions. If x is 1,000,000,000, you basically have 2,000,000,000 over 1,000,000,000. See? Asymptotes. Any asymptotes? None. No asymptotes. Why are there no asymptotes? There's no denominator. You gotta have a denominator to have asymptotes. And we don't have a denominator. How about D?
0.
What?
0.
The horizontal asymptote is 0. Mr. Finn says you have 4 over x squared plus 1. When I try to do that, I don't have an x up here to do it, so I'm going to fill in with a 0. So now I have 0 over 1. That's 0. If x is 1,000,000,000, that fraction's getting smaller. 0. So your horizontal is y equals 0. What about your vertical? Quit watching the clock. I'm going to let you out. What about your vertical? There isn't one, because nothing would make x squared plus 1 0. Vertical asymptotes are where the denominator is 0. And if the denominator can't be 0, then there is no vertical asymptote.
is not again.
Good, Jimmy's right.
Horizontal is.
And the horizontal is y equals 1. X squared over x squared, 1. F, x equals -3 is your vertical, x equals -3, and there is no horizontal, because if you try to compare x squareds, what happens?
Zero.
Yeah, can't be. No vertical, or excuse me, no horizontal. The vertical is x equals -3. And finally, G, our last one. Ah. Bless us, O Lord, and these thy gifts which we have received from the unfruitful grace of our Lord. You have a vertical at x equals 1. You have a horizontal at y equals 1.2 is due on
This stuff?
Yeah, it's on the 1.2. So 1.2 is due Friday.
Oh, which, wait.
1.2 is
So
due Friday.
Finding the even.
Yeah, how do you get that? Oh, I can't remember the formulas for it. That's all you got.
X is right. Remember, you
Like
need
this?
to get horizontal.
My mom's doing it. She never does one.
Stay away. I lose off your class. I've been seeing you.
Thank you.